In this video, we're going to be looking at some HTTPS traffic, so encrypted traffic, and in this case, it'll be TLS version 1.2. Right away, you'll notice that the initial TCP handshake is completed, and following that, we're going to have a process known as the SSL handshake. So to start off with, we have the client sending a client hello to the web server. So contained within this packet is the information that will have to be negotiated between the client and the web server. So the typical options that you'll be looking at will be the TLS version. In this case, the client saying, I would like to set up a secure connection with you. We can use TLS version 1.2. The next ones will be the cipher suites. So this is the ciphers that the client supports that it can encrypt the traffic with. The web server will respond with a server hello, and it'll say, yes, we can use TLS version 1.2, and we will use this cipher to encrypt our information. So right away, we can have issues. If the client and the server can't agree on a TLS version, communication will break. If they can't agree upon a cipher suite, if they both don't support one cipher suite that matches, communication will break. So you'll see the list offered. There's 14 here. These are typically determined by the web browser that you're using, and they will be updated and changed. So I offered this number. The web server will look at its list, say, okay, yes, we have a couple that match. Which one is the most secure? Let's use that one. Where this can cause issues is if from client to server, TLS versions or ciphers we still match, or if you have a device doing SSL decryption in the middle, being a proxy or a firewall or what have you, and say the firewall only supports so many ciphers and the web server can't agree upon a cipher, then the connection will break. You'll see the client hello, and the server will just respond by killing the connection because it knows they don't agree on a cipher. So following this, we'll have the certificate is going to be passed to the client. So this is really important because it allows the client to validate that it's talking to the correct end device. So the certificate will validate that the web server you're talking to is the one that you're looking for. So it'll have a root, intermediate, and server certificate. All those will have identifiers saying this is the server that you want. So the client can actually look up this certificate, see if it's valid. It'll check with the root or intermediate and be like, okay, can you vouch for this guy? Should I trust him? And if you trust the root and they come back and say yes, then you're good. Following this, once they've agreed upon ciphers to use, they've agreed upon the TLS version to use, and the client has validated the web server's identity, an encrypted handshake message will be sent. So the client will encrypt a message and send it to the server. The server, using the information they just negotiated, will decrypt that message, and it'll send one of its own, and the client will decrypt that message. This is used to confirm that the negotiations were successful, both sides are on agreement, and the traffic can now move forward in an encrypted fashion. So if either one of these cannot decrypt this handshake message, something went wrong in the SSL negotiation, and this communication will break. And as we can see here, we have data transfer. And if you actually go ahead and follow, you'll see just garbled information because it's encrypted. So this is kind of the difficulty that SSL, TLS brings to these kind of scenarios. The only information that you can see is the header information. But after a certain point, everything's encrypted, so you can't really perform that much analysis. You either need to decrypt that data or you don't, basically. Or you troubleshoot in other fashions, application level, depending on what the issue is. But yeah, so that was a pretty high level overview of the SSL handshake. It's a really complex negotiation that occurs between client and destination. That's a one-way SSL handshake. So like a certificate is only passed from server to client. You can have a two-way where the client will have a certificate as well, and we'll pass that to the server to say, yes, I'm authorized to access the information. I am who I say I am. And it can get pretty complex. Recommend going and reading up on it because it is a everybody's going to HTTPS now, right? So something that you need to know.